Well, thank you for spending the time with us this afternoon. You had a choice to make. Personally, I think you made the great choice. Our panel will be focused on the future of quantum communication, really applied to network and infrastructure. We'll focus on the promise of quantum and AI. We'll look at the urgency to actually reduce our risk in that context. We'll focus on actions that organizations shall undertake today for a great future. And then we'll close with a vision about, the journey towards a quantum internet. Alongside myself, right, renowned experts. And I think, if you could just remind the assistants about your pedigree and your expertise very quickly, and meet perhaps Michael.
Sure. Michele Mosca. I'm a mathematician by background. I went from a classical code breaker, heard of quantum computing in the 90s, thought it was the dumbest thing I'd ever heard of, but quickly went through, reject, violently oppose, and this is, Schopenhauer's 3 phases. And then I actually met the physicists, and I realized, okay, this is eventually going to happen. So I've been at the interface of quantum computing, did a lot of the fundamental algorithmics and so on, and still always been thinking about cryptography and how to secure the world in the context of quantum computing. So I've been one of the chief translators and chief proselytizers to get ahead of quantum code breaking capabilities so we can focus on the positive capabilities of quantum.
Thank you.
Yeah.
Thank you.
Pleasure to be here.
Donna?
So thank you, Martin, for having me on this panel. I really appreciate it. I'm Donna Dodson. I have a long history in cryptography and looking in this space, particularly at PQC. I was head of the cybersecurity program at the National Institute of Standards and Technology, NIST, under the US Department of Commerce. So as you all know, they recently put out standards around PQC, and before I retired from the federal government, I helped kick off that program with Lily Chen and Dustin Moody and team. And they've done a great job as they've put those standards out. I was also the inaugural director of the National Cybersecurity Center of Excellence, who's done a lot of work in crypto inventory as well as a number of other topics in cybersecurity. Spent some time at AWS and now have the privilege to work with Michele and Martin on some of these challenging problems as we look at how we go from theory to practice in this space.
Thank you, Donna. Michael.
All right, thanks for inviting me to be here. So I'm Michael Eggleston. My background really straddles kind of the domains of science and engineering, and kind of translating fundamental science into something that's engineerable and you can actually productize. And I kind of have the pleasure of working at Bell Labs, where I get to look at really a 10-year vision of where technology is going in order to prepare Nokia. So we have the capabilities internally, the technologies, and are ready for that future. And so my research group in Bell Labs, we really focus on physical devices that span quantum compute, quantum networking, and quantum sensing.
Well, thank you. Thank you, folks. And again, Martin Charbonneau. I'm from Nokia. I'm the head of quantum enablement and quantum safe networks. So needless to say, I believe in the need to become quantum computer safe. But let's start this panel with focusing on the promise of quantum and AI. And I'll go directly to you, Michael, in that context. Like, how does quantum computing and sensing, especially paired with AI, opens up new possibilities for network services and infrastructure?
Yeah, no, it's a great question. It's usually one of the first things I get is, well, how does this relate to AI? And personally, I'm very excited about quantum computing because I think quantum computing, actually just quantum technologies in general, and AI go really, really well together. They're very complementary. The way I look at it is AI is great at taking massive amounts of data and distilling it down to very clear, simple insights. Where something like a quantum computer it's actually good at the opposite. It's good at taking something very small and doing massive computations on it. And so the two will actually work really, really well together. We'll be able to use AI to sift down to small insights and then do large computations on it. Similarly, so really you can think of quantum computing as just really another data source, providing data to AI systems that we just don't have any other way of getting. And quantum sensors are really just another part of that. Quantum sensors allow us to sense things more precisely, really than any other technology. And again, this is what you need to actually get good insights from AI. And so yeah, I think there's huge potential across many spaces. When we talk about networking specifically, I'm very excited about the opportunity for quantum computers to do network optimization, both before you deploy a network, how you set it up, how you actually configure it, but also in how you actually deal with threats, right? So how you actually deal with disturbances in your networks, outages, and potential attacks, and how you can actually prepare for those and optimize those, detect those, and then compensate for them when they actually happen.
Oh, nice. And Michele, can you build on this a little bit by giving us your views on how does AI accelerate opportunities, but also risks?
Yeah, I mean, overall, I mean, AI accelerates, the urgency to have to be quantum ready. It doesn't mean, postpone the quantum readiness because I'm too busy with AI. It actually exacerbates the need to be quantum ready for a number of reasons. For one, quantum accelerates the development of quantum technology, helping, find, better quantum codes, better quantum compilation, helps you match make quantum capabilities with the problem sets out there. Of course, adversaries can weaponize this multiplicative impact of quantum with AI in finding weaknesses, turning vulnerabilities into exploits, and so on. So it accelerates the need for quantum readiness both on the opportunity side and on the defense side, to the point where it's hopeless to be playing whack-a-mole. You really have to just change the game into a resilience game. Just put on padding and shields, and whatever pucks or balls come your way, you'll be fine. So it really, it clearly changes the game into a resilience game instead of the old school 1990s, whack-a-mole of security game. But it's an exciting in a sense, we needed to do this anyway, but quantum is sort of shining a light on it and triggering sort of an immune response, which is getting us to elevate our game.
And would you say AI is accelerating the whole thing?
Yeah, on both sides, both the offense and the defense.
Right.
If we're proactive, I think we actually have a chance to leap ahead on the defense side.
Right. So let's look at the defense a little bit, or the security, right? So we'll just plunge on this for a minute. So the promise of quantum network sensing and computing, if I understand correctly, right, it's built on the premise of never losing trust in the data, trust in the digital communication infrastructure upon which we've built the digital economy. But we're trying to go somewhere, right? We're trying to go to the quantum internet, quantum 2.0 in the promises. What does the journey look like? So maybe I start with Michael and then Donna. But Michael, what breakthroughs in quantum networking and sensing are redefining how we think about connectivity, and what foundational work still needs to happen to get there?
Yeah, no, I think it's a good question, and if I look back 5 years, I didn't really hear anyone talking about quantum networking. Maybe they would say, oh, QKD, that's quantum networking. And I think QKD had a lot of promise of having these secure networks that could, provide this security for us. But there's inherent physical limitations in how far it can go and the fidelity. And I think we're now actually seeing the rest of the quantum ecosystem catch up, right? And building larger scale quantum networks where you can send quantum information over long distances, I think will allow things like QKD over very, very long distance to help improve security. But there's a lot that needs to be done, and I'm actually very encouraged in the last year. You're seeing a lot more actual test beds being developed, people actually trying out these new techniques in real systems. And I think that's really what's needed, because we have these technologies as sciences in labs around the world, but that doesn't secure your network. You actually have to build things, and you have to bring them out into the world and test them. And so I think that's one thing we really need to be focusing on, is running these pilots, actually seeing how this technology works in the field and learning.
I see. And then from a cybersecurity, Donna, and a policy lens that I think you're quite qualified to talk about, what are the most immediate risks that organizations should be addressing today to ensure that they reach this future that Michael talked about?
So as we think about quantum and quantum networking and quantum computing, we need to make sure, and I know everyone in this room understands that classical computers that we have today, that, you know, my computer that's sitting in my laptop is not going away. We all understand that. But I believe when you talk to people in the business world and policymakers, sometimes when they hear like quantum networking or when they hear about quantum computers, they have this vision all of a sudden that we're going to replace our current set of devices with quantum devices, and somehow or another these quantum devices are going to be doing AI. And they get really confused about this, and they don't understand that we are broadening our world so that we're going to have classical computers, and we're going to have quantum computers, and we're going to have devices out there that will bring this world together, and we're going to be able to problem solve faster and more efficiently. And unfortunately, our attack surface for the bad guys is changing. And we have to address this new attack surface from both an AI perspective and from a quantum perspective. And we have to prepare for that, because we, as wanting to have trust and confidence in our systems and in our data, have an opportunity today that we haven't had in the past, because these advanced technologies give us better tools and better opportunities. And sometimes we focus on all the downside, and I get a little discouraged when I hear that. I really get a little discouraged, because we have an opportunity. Today, our infrastructure relies on cryptography as a basic tool to provide trust and confidence in all of our data and our systems, but it's been very fragile for a very long time. And with the advent of quantum computing, we're shining a light on that. And we're shining a light on that because of all the things that you all in this room know about around Shor, et cetera, and Grover, and I'm not going to go through all that, but we have an opportunity to build a resilient cryptographic infrastructure that gives us agility and defense in depth, and we need to take advantage of that today, and now is the time to get started. And it's about strong technologies like implementing the new PQC algorithms that my friends at NIST released, with the whole entire community pitching in and creating those algorithms together as a community and testing them. And we have an opportunity to take a look at technologies like symmetric key cryptography and thinking about places where they make sense at different levels in the stack and with different kinds of devices, like small devices, et cetera. So we have an opportunity. We have an opportunity to see how QKD fits into some of these networks, et cetera. So we have an opportunity to use our imagination and think about how to bring these together so that we have that agility and that defense in depth, and we create that resiliency for the future, for today and for tomorrow, so that we have trust and confidence in our data, and we don't have to worry as much about the bad actors. When they do something, we can say, well, so sorry that you're doing this over here. I have this infrastructure that allows me to have that kind of resilience, and I don't have to worry so much about this one little pinhole over here, because I can accommodate for that. And we're not thinking that creatively.
Right.
Sorry.
And, no, that's great. I mean, that's a great insight. I wanted to ask maybe Dr. Mosca, I've heard the word resiliency, crypto resiliency, from your mouth, from the mouth of Donna as well. Is there a definition?
Yeah, it's basically, we have to be ready in a world of AI and quantum and how the hyperspeed and hyperscale. Resiliency means if the current cryptographic protection is broken without advance warning, we're going to be okay. Doesn't mean it's not going to hurt. It doesn't mean it's not going to be hard, but we have a plan. So what does that entail? So step 0 is, of course, be resilient against the known attack. So it's migrate to PQC ASAP. Step 0. That really should go without saying now. And then as NIST is giving increasing guidance on, and many others, we have to be more agile. Have to be careful how we define that. But so, because this won't be the last cryptographic migration, and again, this is what NIST and others are acknowledging. Now there's the migrations where we have advance warning, and there's those where we're not going to have the advance warning. And if you want to, agility is great if you have the advance warning or if the adversaries promise to wait. If they're not, well, then you need defense in depth. And this is not new. This is like multi-factor authentication, right? We don't only rely on passwords or we have more than one factor. You decide how many factors you need. So that's defense in depth. Now, and furthermore, if you're trying to protect long-term confidentiality, that's not enough either, because you have 2 layers of protection and you're trying to keep a secret, and you break one layer today and another layer tomorrow. You still keep operations going, because there's always one layer keeping the lights on, but you lose the long-term confidentiality. So you do want to have the option of something that is more long-term secure. And we know how to do that. I mean, even before public key cryptography, we would do that through very symmetric key methods, right? So we know how to achieve all those things. We just have to state it as an objective and let the technical teams architect a specific system to do that. And we have to make sure the infrastructures are available to do that.
I see. So more than one tools in the basket, basically, right? So, and if we focus then on the organizational construct, what I'm hearing that this journey is not just technical, right? So it's a strategic initiative that every organization needs to undertake. So what practical steps should organization be taken today to actually be in action, right, in the context of what we just talked about? So maybe, Michele, first question would go to you in that context. Like, what does a realistic roadmap to a quantum-safe readiness looks like? And maybe, if I may, like what pitfall organization how organization may actually avoid the pitfalls?
Yeah, two of the main pitfalls are treat this as a technology problem. UIT people, you cyber people, fix this for me. You're missing the point for many reasons. For one, cryptographic risk amplifies your major enterprise risks. It puts vendor concentration risk, supply chain risk, like it just multiplies it. Because if adversaries can break your cryptography, it's way worse than one vendor like CrowdStrike having a benign mistake turn into a systemic problem. Adversaries can hijack your various elements of your supply chain with very malicious intent. So it's an enterprise risk. And at the other extreme, don't try to eat the elephant all at once, because now suddenly you're like, well, where do I start and how do I immediately fix this? Right. So I think step 0 in our process is, well, first of all, define where you want to go. With any journey, where are we going again? And you want to, it's at a high level, it's simply you want to keep offering the services and functions you normally offer and maintain the trust and confidence of your stakeholders. And of course, you can refine that for your organization, right? And then you quickly assess your strategic posture. And quickly, I mean days, weeks, not years. How ready are we for this journey? And where are the gaps? Again, very quick assessment. And then you very quickly start one bite of the elephant at a time. What's your most important, your top 3 business functions? And how will a quantum-enabled adversary potentially compromise that? So you can start understanding what this means to us. Again, this is a few weeks exercise. This is not years and tons of money. It's very quickly. And in parallel, then your technology teams, because a lot of people start with their cryptographic inventories, which are really important, but they don't really know what they're supposed to be doing with it. They don't know how to connect the dots to my enterprise risk and how does my inventory or migrating this or that system to PQC reduce my risk posture, because they can't. They're just doing the technology side. So, but if you start with this, again, these are really small steps that you can start in a matter of weeks. Your inventory will take a long time, but you don't want to start it without understanding what it's trying to achieve.
Right.
But again, set the goal, start with these bite-sized portions, and know where you're going.
Good. And Donna, do you have anything you wanted to add on this?
I just want to add that this, as Michele said earlier, this is not just a technology problem. It really is. It brings in people, process, and technology. And that leadership buy-in is critically important. It's not just a rip and replace of RSA and ECDSA, and all of a sudden I'm going to put in MLChem and MLDSA, and I'm done, and good for me. I can go home now and sleep well, and it's all taken care of.
Do you believe there's too much of that today in the narrative, in the ongoing narrative?
I think the magnitude of the problem has not been considered. We don't necessarily have a good language to help people understand from a business standpoint how much we rely on cryptography as a tool for our risk management, our enterprise risk management. What happens when you talk? I went into J.B. Pritzker's presentation, and he talked about, when I'm at a block party and I talk quantum, so the governor of Illinois talks quantum, and he says, I don't get invited back to parties anymore because I talk quantum, right?
Yeah.
People's eyes glaze over and they're saying, oh, I'm done, I'm out, this is hard, I can't wrap my head around it. And we haven't had some of those important business conversations. So I think sometimes we have to level up and meet people where they are. And I think some of Michael's great work in talking about the opportunities that come with this kind of advanced technology is really important. And the business opportunities, without trying to explain Schroeder's cat and, and get into all of the depth of all of that is really important to start the conversation.
Right.
And sometimes we get so excited about the technology that we kind of drop
Well, it could be that because even if you talk about cryptography, you may not be invited to the next party.
Oh, come on. Wouldn't I be fun to have at a party? No, that's right. I mean, cryptography is like, they're like, isn't
Right.
that a World War II? And that naturally happens. They're like, I don't understand what that
I
is.
think my big takeaway from listening to you two is, as within an organization, if you leave that topic just in the hands of the technical crew, you're making a grave mistake. Right? You should actually find the right language to actually elevate the discussion to the proper level, start with risk management type practices that will employ technology. Any comment on that? Or?
I think that's correct. And I think the technologists need to be there and have an important role, but it's not only up to them to convince people why this is so important.
Right.
I think the other thing that helps is if you couple it with the opportunity side. Because ultimately we're trying to score goals. We're trying to win. We're trying to
We're not playing defense,
create
just
value.
playing defense.
Yeah, we're not just, exactly.
Yeah.
So we often forget that and we take it but I mean, that gets them excited, like Donna was saying.
Right,
So
right.
It helps to combine it with that. and
Michael
say,
gets invited to all the dinner parties, and we just swoop in behind him.
So let's talk about that skating to where the puck is going to go, right? So Michael, the question is to you now. We're getting close to wrapping up our panel, which is going fast, like lightning fast. But the quantum internet is the long-term goal here, right? So, and we're all here. We know it starts now, right? There is no tomorrow. If it starts not today. We've heard a lot. It has to be secure, right? We cannot lose trust in our digital communication infrastructure. Some action has to be taken today. But how do we build a secure, interworking quantum network of the future? How do we don't lose like this interworking fabric across all of us?
Well, I think kind of in the same thread that you're discussing, I think technology is developed, it's invested in because of the potential it has in the market, right? Like if there's actually upsides that allow you to address a large market, to actually do something new, I think that incentivizes just the way our economy is structured more than defense. And I think we're seeing that in quantum right now, right? The big driver in technology is quantum computing because there's just a huge upside, right? There's markets of $1 trillion plus and completely rewriting how we do chemistry, how we do medicine, how we optimize all of the incredibly complex processes. And so there's massive investment going in there. But to build a scalable quantum computer to do that, you have to create all of these other technologies, things like quantum networking, right? I can easily connect my data centers, that's what the cloud is, but I can't do that with quantum computing because I can't use my normal cloud network, my cloud services, my cloud infrastructure. I have to develop a completely new network architecture to do that. And we're seeing this start to happen. But the nice thing is that this is going to be developed for quantum computers because there's huge market. Those quantum computers provide a threat, but those technologies are also providing an answer, right? So we can use these quantum networks to improve our security, to actually do better sensing, better understanding of the environment. And so I think we're going to be able to kind of ride the coattails of what's causing the threat in the first place to actually improve these networks, build these networks, and therefore also improve our security.
Good, very good, interesting. So, and Michael and Donna, Michele and Donna, in that context, is there a role for the industry, academia, government to really ensure that collaboration is going to be there to not only secure, but actually have an all-inclusive type of quantum internet future? Any views on that?
I would say quantum strategies have to embrace the whole package, right? We can't have everybody just, I want to do this side and I want to do that side. Having a secure and trustworthy quantum internet and quantum ecosystem needs to be the goal, so that you're not fighting for resources to enable with people who just want to enable and vice versa. I think we need to be on the same team, right? How much padding do you need to go make those plays boldly? Because if you don't have padding in NFL, you're not going to make that crazy play diving into the offensive, the defensive line to score the first down. You're going to back off, right? So but you got to work as a team and realize we're all on the same team to create a very prosperous, quantum-enabled and AI-enabled future. So I think that on the innovation side, you need to really architect for that, right? And then on the utilizations, the cybersecurity strategies as well have to both be playing the short-term tactical game and set us up to better utilize the new capabilities and of course defend against emerging threats too. So you have to synchronize both the quantum and the cybersecurity strategies and coordinate toward this end game of being able to boldly and confidently embrace the quantum opportunities.
Good. And Donna?
I think as we look at this advanced technology, we have to understand that adoption and use is not a one-size-fits-all. And how do we provide the right guardrails so that we bring the large enterprises, the small enterprises, the public enterprises, the private enterprises, we bring academia, we have voices, different voices at the table, and we move within these kind of guardrails so that we all have an opportunity and we don't just sit back and wait for nothing to happen because I'm waiting for you, you're waiting for Michele is waiting for Martin, and there's no movement at all, right? And so I think that's really important because everybody does need to be moving, but it doesn't have, that journey is not going to look the same for every organization. So we have to have some kind of guardrails and boundaries on some of this, but we all have to be moving.
Right. So moving in the positive manner, understanding the risk, balancing the opportunity versus the risk, making sure that we get to the end goal. I mean, I want to thank you very much for your insights today. It's a very difficult and broad topic that we had to cover in 30 minutes. But from my key takeaway here is there's great opportunities, but there's some risk, and organizations should take actions to move towards not being just aware, but in action, right? So an organization has to be in action, and if you're leaving this in the hands of only the technologists, you may be missing, the mark a little bit, right? So we need, as an organization, we need to own, how to mitigate the risk. Technology does have great answers, not one size fits all. We've heard about resiliency, agility, defense in depth. I think as an industry, we're working on these topics and these constructs. And stay tuned, because I think the future is bright if we mitigate the risk today. Thank you very much. Thank you all.